Here we have the prototype for the seam detector for standard textile. The way this thing works is there is an analog proximity sensor mounted in a UHMW plastic shoe that is spring-loaded and mounts up against any metal surface that's on the machine. The material slides in between the shoe and the metal surface, and when a seam passes underneath the shoe raises up, and the distance between the sensor and the metal surface gets greater, and we send an output to the machine to signal that a seam has just passed by. We'll go through a couple of items to set this up. This arrangement right here is exactly the same as the encoders that are on the machine right now. So you'll have to mount some 5/8 rod someplace on the machine so that you end up with this arrangement here. There's a spring. This flat piece of steel here is actually a spring that's keeping downward pressure on this shoe, and I really don't know how much it's going to take. Obviously, the least amount of pressure that you can get by with is the best to prevent excess wear. I don't know if heat will build up on this or not. I guess we'll find out once we get the thing running. That's the general design. I tried to stay with the methods that were used in the encoder systems, because those work really well. But that is in general how that thing is constructed. We tried to keep this front panel here as simple as possible to make this system very easy to set up and maintain. Essentially, you have a stoplight display here that gives you your material thickness while you're running, and a calibration button, a sensitivity adjustment, and of course a on-off switch. We'll go through a little bit of the setup here. The first thing you need to do, of course, is get your material, whatever material you're using, set up, sandwiched in between the shoe and the machine. The next thing you need to do is we need to make sure that this sensor is in the middle of its sensing range, with the material sandwiched in between. So what we'll do is we'll look at the light that's on the calibrate, and if I bring the sensor further away, the light goes out. Bring it in, comes on. Go in too far, it goes out again. So we're looking for that sweet spot where the calibrate light is on. Once you make this adjustment here to get your calibrate light to turn on, that's the first step in the process. And while you're doing that, don't really pay attention to what these lights are doing. It's irrelevant at this point. So once we get set up to where we're in that sweet spot, we will calibrate for this material. What that's going to do is say, okay, whatever thickness it is, let's call that okay. So we hit the calibrate button. Now we're calibrated for this thickness of material. So as this thickness gets greater, as in a seam passes by, we see the seam detection light up, and also inside there a relay clicked that will signal the machine. Now the seam detector, even though I let go of it, it stays on for 3 seconds. So we make sure that the machine has time to read the relay that's clicked inside there, and we don't want that to happen too fast and the machine misses the whole the relay. So if we get too close to the material, we're no longer really sensing for a seam because we're out of calibration. So we've got a green light down here that says I've marked it as too thin. Really, we're just too close to the plate. Something's happened with either the material is no longer in calibration. Something's wrong. When the material is running normally, we should see the yellow OK light right here. And as we encounter a seam, it raises that shoe and gives us a seam detection light. Okay. Now, while you're running, you may find that you're either missing seams or the thing keeps shutting your machine down even though there's not a seam there. This dial right here is a sensitivity adjustment. If you turn it this way, the system is less sensitive to changes. So you will need to see a bigger seam pass by in order to trigger the detector. If you bring it this way, it's going to be more sensitive. So that's something that you're just going to have to play with while it's running to see if we can get a stable system that continues to run when there's no seams but catches every seam that goes through. So it does catch it pretty quick, and you can see it stays on for 3 seconds. Even though that seam whipped by there in a couple of milliseconds, we still hold that relay and that light on for 3 seconds no matter what.